Hello everyone. So today in this video we'll be discussing about the most famous problem that is also known as the Brachistrochrone problem. And this problem I have already posted in my community post during the afternoon. I posted that you must learn about this. You may view some articles, all those. So hope you have done those things. And now I'll be sharing some insights about the Brachistrochrone problem. Now, Brachistrochrone problem says that suppose you are throwing a projectile and this projectile is under a gravity g in the positive y direction and this reaches a point, suppose it to be x comma y. You have to tell me the path or describe the path of the projectile so that it reaches the point x comma y in the minimal possible time. Basically, you have to find the minimum value of time t. Okay. So before that, we'll be introducing some concepts that suppose you have an integral f of y dx from x1 to x2 where x1 x2 are fixed constant and f of y is a variable. Okay, and this is L. We have to basically maximize the value of L. For that to happen, what we must take care is we must take care that f of del of fy by del y dot del y dash or y dot where y dash is equals to dy by dx. Note that this is partial derivatives and the differentiation of this with respect to x is equal to del fy by del y. So this is the basic concept we must know that for any function to be minimized, it must satisfy this formula, and this is also known as the core of Lagrangian mechanics. Because in while solving the Lagrangians, we basically apply this theorem. What is the concept in Lagrangian? The concept is that we introduce L x comma x dot comma t, and here f of y also involves terms of y dash and x also, and we define in case of Lagrangian is L x comma x dot comma t into dx integral. Basically, this value is to be minimum. We will define L in some other video. Generally, we write L is equals to k minus t, where k minus u, where k is the kinetic energy, u is the potential energy. For now, I am just defining what is the core formula. Core formula is del L by del x dot into d by dt is equals to del L by del x. Similarly, in this case also I define the same thing. Just here instead of x it is t, and instead of y it's x here, and y dash is corresponding to x dot. So just we have to satisfy this equation. Now, one thing you must know before solving, that is if L is suppose f of x into under root y plus uh, let us suppose f of y plus 1 plus y dash square, then the equation is given as b f of y square is equals to 1 plus y dash square. This is the required equation so that the integral is minimal or extremal as per the requirement. Now for this case where it's a projectile, consider a small displacement of ds. Now I can write ds to be under root dx square plus dy square. So I can write it now, taking dx common, we'll get under root 1 plus y dash square plus into dx. What is dt? Dt is in ds by v, which will come out to be under root 1 plus y dash square dx by root 2 gy. Basically, we have to minimize this integral, and this integral ranges from 0 to some x naught. I'm considering point P to be x naught comma y naught, right? Now, can you relate this to be similar as that one, which is equal to basically 1 by root y into under root 1 plus y dash square. So just f of y is equals to 1 by root y. Hence, you will get b by y is equals to 1 plus y dash square. Thus b minus y by y is equals to under root is equals to dy by dx. I am taking the positive sign for now. Hence under root y by b minus y is equals to dx. Now we have to just use substitution so that we can integrate properly. I'll put y is equals to b sine square t. Right? Putting the values, I'll get dx is equals to tan t into what is differential of y. It will come out to be 2b sine t cos t dt. On further simplification, we'll get 2b sine square t dt integral 0 to t, and just using multiple angle formula 1 minus cos b into 1 minus cos 2t dt integral, you will get final result to be b into t minus sine 2t by 2 plus some constant c. Similarly, we said already that y is equals to b sine square t, and this is the formula for x, and y is equals to b sine square t corresponds b into 1 minus cos 2t by 2. Now when t is equals to 0, x equals to 0, so basically c will come out to be 0. Hence, if you are familiar to cycloid and cycloidal curves, you can see that this parametric form usually represents a cycloid. This is basically a cycloid. Something interesting to note. We know that cycloid is basically generated by a point on a sphere or a rolling disc, right? So basically, what we obtain is also known as a cycloid. Now, what I have posted in community post, hope you understood it, and you might have seen most of the problem using the Lagrangian to prove the Brachistrochrone. Well, there is another method of using light. The concept of light is also useful to solve this problem. Well, I'll post a problem regarding it. You can see it. It's from NBPHO 2019. Give it a try, and the concept behind it, I am just briefly describing it. You might have seen problems like suppose here is a grass field, and here is my rock field. Your house is somewhere here, and you have to reach some point here where there is a nearby store, and your house is at a distance d1 from the grassland, and the store is at a distance d2 from along the vertical, and this distance is given as some l. Then what we usually do is that if the velocity of the person on the rock is v1 and velocity on the grass is v2, we generally use the concept of refraction, so that if a light emits from the house, it goes to the store by the method of refraction. So the similar concept can be applied for Brachistrochrone problem, that is this curve, the curve which is stated previously, that is this curve I am marking by blue, basically follows the path of a light where here refractive index is infinity, and you can find refractive index as a function of y, as we know v by mu v is equals to constant. So I'll take c is equals to mu v, where v is equals to root 2 g y. So you will get mu is inversely proportional to root y, and hope you have seen some problems regarding solving continuous and variable refractive index medias, where light is going almost to 90 degrees, then it bends to by some angle, and you have to solve it. So I hope you can deal with such problems. Hope you enjoyed this video. Thank you and have a nice day.